Hello everyone. So this is the new topic. We are going to solve this question on this topic. So this is the always block topic. Okay. So here in the several times while writing code, we are using always block. Okay. So see here little bit theory has given. So we just read it these things. So here always block we can use in two types, like in the combinational way always add this asterisk sign. Okay. And in the sequential way always at the rate pause clock. Okay. So here what is the meaning of this asterisk sign? So at any changes in the signal this always block will execute. So this is the meaning of this asterisk sign. In here always at the rate pause clock, for each pause age clock this block always block will execute. Okay. So based on this sensitivity list, this always block will execute. Okay. See here either we can use this assign this data flow modeling, right? This assign out 1 equal to a and b or c XOR d. So either we can write like this or we can use this always block. Okay. So in the both way we can write. Okay. So here one question is given. We need to write the code for AND operation, and we need to write in the both way, means by assign statement and by using the always block. So let's write this. Here two inputs we have given, a and b. We have two outputs, out assign and out always block. Okay. So this out assign is for the assign statement. Okay. Out assign equal to a and b. Next, here in the next this output we need to use always block. So I'm writing always at the rate asterisk sign. Okay. In this always block we can write begin and end. If we are writing multiple statements, then we can write begin and end. If there is only single statement, then no need to write this begin and end. Okay. So here what we can write, what is the output? This one is the output. So out always block equal to a and b. Okay. So in this way we can write this one. So for any change, any signal change, this asterisk sign means any signal change, this block will execute. In place of asterisk we can write a or b. So for any signal change in a or b, this block will execute. Like that also we can write. That is also true. Okay. So let's see here we did one mistake. We did not wrote assign out assign. Okay. So this is the assignment statement. We can write like this, right? Let's check it. Okay. So whatever we wrote, that one is correct. Okay. So let's solve one more question. This is the second question. In this question, they have given this blocking versus non-blocking assignments. Okay. So here, this one continuous assignment, like assign x is equal to y. This we can use outside of this procedural block, that is always block. Okay. And this blocking and non-blocking assignment we can use in the inside the always block. Okay. So when we can use this blocking and when we can use this non-blocking, we will see in this question. Okay. So here they mention little bit theory and they have given one question. So here two inputs they have given. Okay. A and B, and we need to perform XOR operation. So and there are three outputs: out assign, out always com, and out always ends. here we need to write in a three way XOR operation in a three ways. Okay, with the help of assign, with the help of always add rate this asterisk sign, and with the help of always add rate pause clock. Okay, so let's write this code. Assign. For first I am writing for this one. So how we can perform XOR operation with the help of assign statement? We need to just write assign out assign out assign equal to A XOR B. This is the symbol for this XOR operation, right? And in this way we can write this XOR operation with the help of assign statement. Okay. Next, for this output we need to write always block with this always at the rate asterisk. So this is for combinational logic. Okay. So in this always block clock is not there. So this we can see as a combinational one. And here in this always block clock is there. So this we can see as a sequential one. Okay. So for this always block we need to write this code. So write always at the rate asterisk. Next begin end. Okay. So here what is the output? This one output. Out always com. Out always com equal to A XOR B. Right. So for any signal chain, this block will execute. Okay. That is the meaning of this asterisk sign. So in this way we can write this write for this combinational one. Okay. Next we can write for this always at the rate pause clock. Always at the rate pause clock. Begin end. Okay. So here what is the output? Out always FF. Out always FF equal to C. Here what is the blocking assignment? This one equal to is the blocking assignment. Okay. And what is the non-blocking assignment? Is less than equal to this one. This is the non-blocking assignment. Okay. So for this combinational means when always at the rate asterisk sign, or if there is no clock means in that place we can use this blocking assignment. Okay. And whenever there is a clock involved in that always inside that always block we need to use this non-blocking assignment so that we can achieve the synchronization whenever there is a clock involved in that always block. Okay. So if we use the blocking assignment in this always block where the clock is involved, then we might face the asynchronization in that circuit. So to avoid that one, we need to use the non-blocking assignment in that always block where the clock is involved. Okay. So here we need to write non-blocking assignment in place of blocking. Okay. Next, what we can write? Same A XOR B. So this is the code for these three output. Let's check it. So whatever we wrote, that is correct. Our code has run successfully. Okay. So in this way we can use these always blocks and we can solve questions. Okay. So we will solve more questions on the upcoming videos. Till that, thank you.